Good afternoon, everyone, and welcome to the webinar today. Our title for our webinar is Shield and Isolate Critical Assets from Cyber Attacks with Unidirectional Security Gateways. If everyone can hear me, please click on the little thing to raise your hand and make sure I have audio. I see that, thank you. So this webinar today is brought to you by AutomaTech and CB Pacific in partnership with Bayshore Network. Today we have with us Tom Schiller, President of AutomaTech, who will be our moderator. And our guest presenters are Kevin Senator, President and CEO of Bayshore Networks, and Vincent Trumel, who is the Vice President of Technical Operations for Bayshore Network. This is going to be a short webinar. It's planned for 30 minutes. Everyone will be on mute so we can capture a clean recording. However, if you have questions, please submit that through the Q&A module in the Zoom platform, and we will address them at the end of the presentation. So in the interest of time, I'm going to go ahead and pass things over to Tom.
Thank you, Carrie. Appreciate that. Good morning, everybody. Welcome to the Bayshore Networks webinar. AutomaTech and CB Pacific here have partnered with Bayshore to bring you some of the latest technology and such a hot topic right now, especially having to do with cybersecurity and what's going on in the world, and being able to protect our manufacturing and utility plants is critical for us. So I'm going to do a quick introduction about my team. So I am the president of AutomaTech as well as the president of the Flow Control Group automation group, which consists of 3 companies, Simtech, AutomaTech, and CB Pacific, and we continue to expand our team. Our mission is really to provide the ultimate in technical support and service. We have 2 headquarters, one on the West Coast in Kirkland, Washington, as well as Plymouth, Massachusetts. We focus really on manufacturing and utilities, providing global support and enterprise-wide support for customers all over the world. Yes, we're located in the East Coast and West Coast, but we support teams all over the world. Today, we represent different technologies focused around automation, controls, industrial connectivity, data analytics, cybersecurity, and Internet of Things. So we continue to bring you these technology. We focus and heavily partner with people like our system integrators, our OEMs, our consultants to provide you with a complete solution. So whether that's our suppliers providing cyber technology like we're talking about today, or manufacturing technology, all of it key to improving the operations of our manufacturing and utility facilities. We have certified trainers, we provide seminars and webinars, and hopefully soon we'll be providing these technical conferences face-to-face with many of our customers as time goes on. AutomaTech and CB, as I said, are located on the East Coast and the West Coast, and just a little bit of our team here. I'm going to not repeat everything that's on this slide. We provide that enterprise support across for our customers all over the world, both pre- and post-sale support. We have solution architects that will help you with your pre-support for all your sales efforts, whatever you need in your applications. Our team's here to help you architect that solution. We'll bring our team as well as our suppliers to the table to help you design this. And again, we're going to continue to bring you more training, seminars, and webinars. Next slide. Our key technologies that we focus on today: HMI, SCADA, and automation. So that's the PLCs, the controls, the drives. It's our HMI SCADA. It's all the notification, mobility, everything to do with visualization and control in a plant. Also the manufacturing optimization, MES, reporting, analysis, industrial IoT technologies, remote monitoring diagnostics, edge connectivity tools, equipment optimization, energy management, predictive maintenance. All of these solutions, we bring you the right suppliers for that. We also provide you the systems and network architecture for this as well. So whether it's the servers, the industrial connectivity, the industrial computers, all of that we have access to bring you. And cybersecurity, which is what we're all about today, bringing you assessments, the appliances, and the software to provide you the real strength that you need to protect your facilities. So with that, I'd like to turn it over to Vincent Trumel from Bayshore Networks, and he will tell you more about what we're doing today with technology and some of the latest and greatest things going on with Bayshore. Vincent?
Thank you, Tom. And thank you very much for the introduction. And yes, Basho is really focused on operational technology network security. We have our key technology, which is really a combination of deep content inspection, policy enforcement, and learning so that the policies can be automatically created and managed. And based on this, we really have 3 broad product lines. This is what we're going to, focus on one of them today. So we have our OT Fuse product line, which is really meant to be a cabinet level protection, creating segmentation when there is none, protecting at the PLC level, at the cabinet level. So the idea is to have an inline device, which will be monitoring and actually preventing any unauthorized access to these trusting devices, which are PLCs, right? They would take commands and even program often from anyone which has access to the network. So that's one of the product line of Basho. Using the same technology of inline inspections, we have a remote access solution, which can be both appliance or cloud-based or as a VM, which really have a very fine granular access where you can really give device level access with limited connectivity to only single protocols and maybe even some read-only commands if you wanted to, or actually a much broader access to remote users. And then today we are here to talk about NetWall, our Unidirectional Security Gateway, which is really there to create a physically connected link to get data from one side to another, from a network to another network, which are not connected. So the idea is really to enforce one-way secure data transfer. And one of the key advantage of NetWall is we have guaranteed delivery. And we also have capabilities to send very different type of data across. And very quickly, why would we want to do that in the first place, right? Well, if you have a truly isolated network and you have data which are valuable and you want to share with the outside world, you only have really 2 choices. The first choice is what is happening in many organizations is you actually end up connecting your network, right? You create a connection and you try to put some firewall and defend that as much as you can, but you know that over the years, over time, you'll be more and more connections and your firewall would look like more like Swiss cheese than anything. And you hope that somebody maintains the firewall rules to figure out what's really going on. The alternative to that, ever you get the systems connected to the information you need. So for example, connecting your corporate network, or you actually even have remote users coming into your protected network, which is really a trusted network. The alternative is to use a solution like NetWall, where you actually, instead of giving access to your network to the systems or people would need access to them, you actually you replicate this data to the outside. So you would copy, whether it's a file, if it's copy files or databases or entire historians or even entire HMI servers, there are mechanisms to create a replication in near real time of this data to the outside on other network and without creating a network connection. That's really the key. Then you can actually, you don't have to manage access to this data because, you don't have to connect your network. You can stay isolated. You just push the data across, transfer the data, and then whoever needs to have access for, other system, third-party users can actually access that. Now, you have your trusted network, which in our case is typically a plant network, an ICS network. On your untrusted network, untrusted can really be your corporate network. It can be your customers, your suppliers for which you need to transfer data or they need to know what's going on in your plant. So that's really the key idea. So traditionally, data diodes have been doing that job, right? They've been around for quite a while, and the principle is very simple. They use an LED, optical fiber. They don't have a written fiber. They just send the data through an optical fibers. They don't have any feedback. They don't know if there's anybody even to receive the data. Because of that, that means you need to get repetitions, and synchronization is always a big issue. So depending on the variant, you might have a second pair of transmitter receivers in the opposite direction. Here we're talking about two-way data diodes. It's a bit, it's the same concept. The idea is to be able to get data coming back. So this whole category of products are called boundary protection products under the NIST standard. And over the years, they found their place. NERC is, allowing reduced audit for these kind of systems when you have electronic security perimeter in place. And generally speaking, this is very expensive and cumbersome systems, which are very hard to implement. And outside of, obviously intelligence agencies, military and large utilities have, limited market capabilities just because of implementation cost and complexity. So really it's utilities, maybe big oil companies and government which are using this kind of product. However, we realized that, our plants used to be isolated for the longest time. And then over the last decade and a half, they're becoming more and more connected. In even sensitive area, there's really a need to connect assets or to send the data. And at the same time, there's so much risk out there. Just have to open the news every day now. It used to be like once a year, then once a month. And now every day there's a cybersecurity incident in the news. So providing that kind of isolation is more and more important than ever. The data diodes are defined by design. And again, the isolation could really benefit many more organizations and systems than that what is totally what is used today. The challenge is, we're dealing with a lot less organized and structured physical segments, right? Physical networks. And there's very little control. If you look at a typical ICS network, well, it's most of the time very flat. There might be VLAN routed together. And there's really no access control, very little access control. A PLC takes a command from anyone on the network. It doesn't check what your credentials are. And this is why we believe that there's really an opportunity for NetWall, be also due to the ease of implementation and really lower cost of the solution. So now what exactly are we talking about, right? We're really talking about exporting data without any risk for the internal network. So we create really an isolated segments. We keep the isolation. We can do application like file transfer, database server application without a networking requirement. So we can guarantee the delivery. So you don't have the issue of endless retransmission. We would know if the data don't get there, and we can actually send the information back. There's also a full insulation against any kind of malware and exploit because there's actually no way to get data back into the trusted network. And we do that with a cost saving of at least 60% of a competing solution. Exactly, how does that work? In practice, we have two servers which have connected via a non-network serial connection. So it's non-networked. There's a serial link between these two computers. It's a really fast serial link. We have what we call the blue server on the trusted side, the trusted domain, which is sending data to the red server, which sits on the untrusted domain. So red is receiving data sent by blue. That's really the way it works. They're connected by a PCIe cable. We have specialized PCIe interface cards in them. And all the configuration is done on the blue side. So you do all that from Windows interface, and you do all the configuration of both servers, including the IP addresses on the red side, for example, basic things like that. You do everything from the blue side. You don't need to ever access a command line or anything like that. Actually, SSH is disabled on all these machines. So what is going on is there's a shared memory on the red side, and blue can read and write shared segment on the red side card. Red has no ability to do anything equivalent on the blue side. There's no shared memory there. So even if somebody had root access to red, could recompile the code, run everything they wanted there, there's no way for them to push data on the trusted side. All they could do is denial of service. It would prevent data from going out, but there's no way for them to inject data in. So in terms of security for configuration, we have a Windows console application. We're using crypto dongle to protect the setup and the administration. So we really believe we have a very secure configuration at that level. So what can we do? Basically, we can send any type of TCP or UDP unidirectional flows. So UDP is typically unidirectional, so that's simple. For TCP, we can send any kind of TCP connection. They will be always ending on the blue side. Data would be, the block of data would be reconstituted, move through the serial cable to red, and red would start a connection on the red side to the actual destination. So that's really what we can do. We're doing file transfers. with content inspection. So we check for the file type. Again, we do inspection of a full file. We make sure that we understand what file type it is. Is it authorized? And if it is, and there's no threat, we have a little threat intel, we do a check. And if it's all fine, we'll just push it to red, and red will push it to the destination. We do also OPC UA, DA, and AE replication, Modbus replication. All that is as standard, all included in the standard device. And we do all that in a one-way mechanism, right? It's only one path from blue to red. There's no return path. So there's really no network protocol. There's no network information being passed across. Only the data gets stripped, pushed through serial connections, and then there's a new connection going on the other side as needed. So that can seem a little complicated, but in reality, we have this patented guaranteed delivery mechanism on multiplexing sessions so that we can actually do multiple sessions using the same protocol. We can do multiple protocols at the same time. So you can have a OPC UA replication at the same time as moving files across. So that's actually pretty useful. The device is gigabit capable. So we're using the same hardware, and we have version at 50, 100 on 1 gigabit throughput. The actual connection between the two devices, the two servers, is up to 40 gigabit. So that's not the bottleneck here. There's no problem. The hardware is really invisible. The configuration is very simple. Because most of the time the protocol depends. Each protocol is different, right? Each transport is different. But it allows to have a lot of flexibility, and it is suitable for a wide range of ICS, SCADA, system use, and even IT applications. We can send syslog, etc. We have one type of hardware, and the license, there's just a licensing which is changing the transmission speed, the throughput of a device. So if you are purchasing a 50 megabit system and you realize it's too constrained, it's very easy to just change the license to move it to 100 meg or even a gigabit throughput. That's just a quick view of the configuration. So this is from this Windows application. You will be modifying the key parameters, from the two servers, like IP address and FTP, Windows file share. And you see there are also all sorts of different configuration for different type of protocol. We could go through, if anybody is really interested, we can do individual sessions with demos, etc., to go through that and really try to tailor, explain how things would work for your applications. But in practice, what is supported? So the TCP stream we can do any kind of replication, OPC, Modbus, file transfers. So we do replicate the handshake. The handshake is possible. But a lot of TCP protocols require data to come back. So that won't be working natively. For UDP, it's very straightforward because UDP doesn't expect any replies. So, we can things like TFTP, syslog, MQTT, SN would work seamlessly with nothing to do except configuring in NetWall what's the source, what will be the destination, and then pointing the source to NetWall. And NetWall will take care of the rest, which will really move the data across in real time. For file transfer, we've got FTP and then standard Windows SMBC file shares. We have the application for that. And then for OPC, we have different variants. We've got OPC UA. We can send data. We have tested up to 50,000 points in real time. So in that case, NetWall Blue server acts as an OPC UA client. You would be loading your certificates, so that you can actually get even the encrypted data, move data across, and then Red would have its own certificate to load on the client on the untrusted side. So for OPC, DA, and AE, as it is Windows, it's really Windows based. So we have DCOM services to act and to install on either the server or on flanking servers. So, Modbus is also very straightforward. Modbus, NetWall Blue is a Modbus client. It would collect the data from the sources defined at the frequency you define. So if you want these 200 points being collected every half a second, that's fine. And then Red would be acting as a Modbus server and would make this data available immediately. So if you look at an example of a file transfer application, it's very simple, right? You would be defining what's the source folder, even FTP or file share. You would be looking at, the NetWall Blue would be scanning for new files or new folders inserted there, read them, inspect them, push them across to Red, and Red will push them to another FTP server or file share on the untrusted side. Very transparent, and this is again through a one-way one-way connection with no feedback path. For Modbus, same thing, Modbus client on Blue, we're reading the data straight from the sources, push them across on Modbus NetWall Red is Modbus server, and then any kind of Modbus client can access the data. So again, that's the alternative, is giving access to the outside Modbus client to the sources directly. And if you don't want to do that, then NetWall is a perfect solution for this. OPC UA, so you can do replication of your historians, full servers. We have actually in our lab a full HMI server being replicated that way. So again, one-way connection, so that if people want to know what's going on in the plant, but really you don't trust them, you can have a copy of your either the historian if it's data, or even the full HMI server on the outside for them to be able to see what's going on. And if they have no way to actually manipulate anything on the plant, it's just a mirror image of what's going on the plant. For DA and AE, again, I mentioned we can put flanking servers. Usually you install the software directly on the OPC servers, on the OPC client. Otherwise, it may need to put Windows-based flanking servers. And again, the data path is very straightforward. Now, we have a separate version of NetWall, which allows bilateral communications. Again, let's be clear, there's no way to start a connection from the outside, but what it does, like a two-way data diode, is allows data to be returned from a communication which is initiated from the inside. So when data is, when triggered on the blue side, the red side is allowed to respond on the specific condition. Again, blue will never push data to red. The red server will, red will never push any data to blue. Red will put the data he wants to return in a special memory segment, and blue will read it as appropriate if it's defined that it's allowed to do that if it's a bilateral connection. It's the same hardware, but we are running a different version of software in it. We want to make sure that there's no way to do a return path on the unilateral version, the unidirectional version. Again, traditional data diode vendors have similar capabilities using different hardware. They have this two-way data diode. And why do we need that? We need that for specific applications such as Microsoft SQL Server transactional replications. We use that also for iSpentech IP21 historian replication. And we're doing that using their native tools. So that means we don't need to have very complicated scripting and rules, etc. We can use the standard, for example, the standard Microsoft SQL Server replication tool to actually have transactional replication through NetWall. And the configuration of NetWall is extremely simple. And the configuration of a replication is exactly the same as if you didn't have NetWall, if you're trying to replicate in another server on the same network segment. So again, it always has to be initiated from blue. It always has to be predetermined. And that is really the way the system works. So, for Microsoft SQL Server, that's actually the latest thing we've released. And we just released the bilateral version of NetWall. And that allows to really do that without any kind of complicated scripting or any kind of specific customization. So that it means when you modify your database, you don't have to modify all your scripts or anything else going around it. So in that case, it's a bilateral connection, which just means that the replicated server can actually reply to queries from the initial, SQL initial database through the NetWall by BSG. You've got the USG for unilateral and the unidirectional on the BSG for bilateral. If you look at version on pricing, so I mentioned it earlier, we have two versions, unilateral and bilateral, and you really have, these are different part numbers. You need to specify that. If you have a wrong version, you need to wipe out everything and reinstall everything. It's not a license upgrade, right, for that. But in terms of speed, the hardware is the same for the 50, 100, and 1 gigabit version. and you can just a licensing which can be easily upgraded to move from 50 meg to 100 meg, for example, or to 1 gigabit. Now we are about to release in June, so I guess June is a week away now, a 10 gigabit version of NetWall. That's a unilateral version only. It uses a slightly different hardware. Obviously, we need a little bit of compute power, and we also need to include different networking cards to interface with both the trusted and untrusted network. So that is the big difference there. The pricing starts at $15,000 for 50 megabit. And then we've got $20,000 and $30,000 for 100 on the 1 gigabit. So that pricing includes everything you need, all the software you need, the appliances, obviously, and it also includes the first year of support and for software upgrade support, and also, of course, hardware warranty. The 10 gigabit version will be priced at $50,000, and that is really for very high throughput applications. You have to think more about on the IT level kind of application, but this is definitely something which has a space in the market. And the good news is we have a special offer for the participant of this webinar. Is we will be offering a free second year of support if you order in the next 3 months. And of course, the first year of support is always included, and the second year, which includes both the software upgrade, of course, obviously the support, telephone and remote support from Basho, and also the hardware warranty, which is priced at 20% of the initial price, is offered for free in this case. So, I just wanted to have a quick recap of where NetWall fits into the Basho solutions. So NetWall is really to export data. It's the way to do that from the plant. But we're also offering protection solution for low-level devices with OT fuse, and also remote access for OT access. I don't expect customers to buy at the same time a NetWall for isolated network and OT access to remote into their isolated network, but you never know. So that is really where we are, and I think it is time to take questions now.
Yes, thanks, Vincent. Actually, why don't you leave that last screen up? I still like that last screen that you've got. It really highlights where Bayshore fits in the whole application. And I think this first couple of questions that I have might actually be in that area. But just for anybody else, if there's any questions, please don't hesitate to ask them. So let me just start off with this first question we've got. I think somebody out there has a project. I think you might have hit on this a little bit with your discussion. So if I've got a SCADA in my network and on the OT, and I've got to go through my business network and through a DMZ, but my data is stored in my process historian, can we allow the SQL data to pass in a single direction through the DMZ? Okay, so if you look at NetWall is, you could use NetWall to go from the, the control network to the corporate network. So you need to have a DMZ in that case, right? And what we would do is we would allow replication. The question is, how are the data being sent from the SCADA system to the destination? The issue here, it's not the issue, is really what it is you can't interrogate the database through NetWall because the data are always inside out. We don't let requests coming from the outside. Even if we let a reply from, for example, a replicated server so that we can do transactional replication, we need to check the status, right? But we would never let any kind of clients or anything else making a request through NetWall. That's not the application we're doing here. So the way to do that would be to replicate the historian, and then your outside parties would have can query that replicated historian, but not the original one. Yeah, thanks, Vincent, on that one. We kind of recommend our clients, and a lot of times, especially in life sciences, to have the historian inside the network, and that be something that's used in the plant, and then replicated outside for the business user. So, great point there. I got a couple more questions here for you. So, many vendors are offering SCADA solutions in the cloud nowadays. And let's say there's a web-based real-time SCADA, and it's for visualization only.
Yep.
No control. Can NetWall offer additional protection between the web server SCADA and the plant floor?
Yes. Okay, so NetWall could, again, we have to be careful. It really depends on the communications, what is going on. But yeah, it actually totally could that. We've done that kind of applications. I'm sorry, Tom, but we have a full HMI server. We have a full ignition HMI server. So the thing to do here, again, you would be replicating maybe your HMI environment, your SCADA server on the outside, and then you let the users do whatever you want. You might have your human protection, making sure they can't change any data, but even if they do, it doesn't matter because it's a replicated copy. So they see what's going in the plant. They don't actually touch the real system. Because if you want to do the NetWall lower, below the SCADA system, you'd have to put it between the PLC and the SCADA servers. And again, here, a lot of the time, you have a lot of queries going back and forth, right? It's not the PLC just sending its data. There's a lot of interrogations and also feedback coming in. So usually NetWall fits at a higher level. Again, we have the ability to get Modbus data, to get Modbus through. We have Modbus client server. But that's really, we'd have to look at really the specific of the application.
Yeah, does it matter based on the protocol that they're using, or I mean, it's for this application, I think based on.
It does because things like if you look at Ethernet IP, for example, you can't even create a connection if you can't write. So it's if it's one way, there's no way you can even create.
Would you use the unidirectional then for that?
Yeah, I mean,
bidirectional.
Even the bilateral, let's reply, but never lets anything started on the other side. So really, NetWall is a higher level, at level 2, level 3, but I wouldn't put it between a PLC and a SCADA system. If you want to do that, use OT-Fuse. That's really what you
OT-Fuse. Okay, yeah. So we have other products that'll solve that problem. Yeah. Got it. Does this one? Next question here. Does this product work with OSI Pi historians?
OSI Pi is actually, the replication of OSI Pi is kind of complicated, and it is something we have on our roadmap to do. It's not as simple as just putting a stream connection. We have people in our staff which have done that before, and it is definitely on our roadmap for the. I don't want to give a timeline, but hopefully by the end of the year.
Okay. All right. So next question. Do you have transaction or size limitations when passing data from the OT to the IT network?
No, we do not. I mean, for example, for file transfer, what we do is we give the choice to the user. If they want to transfer a file over 2 GB in size, do they want to have it inspected or not? Because we put the limit at 2 GB because we need to be able to basically explode the file in memory to do the inspection. So we can still get files bigger than 2 GB through the system. We just can't do any kind of inspection of a file because it's too large.
Okay. All right. So I think we have time for one more question for you, Vincent. And first off, I also want to say thank you for your time and also that great offer. So anybody who's on this or listens to this and wants to talk to an AutomaTech salesperson or technical person regarding the products from Bayshore, you get that special promotion that includes a free second year. So just wanted to remind everybody of that. So last question. So what setup is required by the end user on delivery? Do I have to install any software or set up licenses? What do I have to do?
Okay. So if you, for most applications, you don't need to install any software. Well, actually, you need to install the Windows console software for NetWall on the computer to manage it, or Windows console. And then everything is done from there. The only extra software you may need is for OPC, AE, and DA. But other than that, you just need to configure the connections, what are the sources, destinations. You might need to put some credentials, right? For example, for file transfer, and things like that. But otherwise, the configuration of a system of NetWall is very simple. Now, it doesn't mean the whole configuration is simple because you still have to deal with replications, right? You have to set up maybe your FTP server, replicated FTP server or file share. If you do OPC UA replication, you need to have your destination set up as well, right? If you do SQL Server, well, the NetWall setup is extremely simple. What's less simple, you still have to set up your transactional replication for Microsoft. So you still need to know how to do that.
Okay, great.
But NetWall itself is very simple.
And of course, we have the Bayshore team and the AutomaTech team to help out, right?
Absolutely.
Okay. All right. Well, that wraps it up. I think we did a couple minutes over here on the time, but great questions from the audience. We had a great audience today. So thank you very much, Vincent and the Bayshore team, and everybody else. Have a great day. Thank you.
Thank you very much, Tom, on AutomaTech and CB Pacific, and everybody attending. Thank you.